Okay, so we're going to keep going on these problems. The graph below shows the weight of three objects on planet X as a function of their mass. This is a lot like question 49, so we're going to do both these at the same time. Now, if you look at these, you see weight versus mass, and it's asking you about the acceleration due to gravity. So if you use the equation from the reference table, G equals F sub G over M. F sub G is y-axis, that's the weight, mass. Weight over mass is equal to G, the acceleration due to gravity. This is just a variation on the equation F sub G equals mg. Weight of an object equals mass times G, the acceleration due to gravity. G on Earth is 9.8 meters per second squared, so you're going to see that probably in both of these. However, we're on a different planet. So the slope of this, let's see, goes up. I'm just going to pick from 0 to 0 to 300. So it goes up 300 and over 50. You can find the slope with x and y coordinates too. But 300 divided by 50 should be 6 meters per second squared. This one goes up 32 and over 20. Or you can do up 8 over 5, however you want to do it. 8/5, which has got to be 1.6 meters per second squared. 3 kilogram mass weighs 15 newtons at a given point. So, in the Earth's gravitational field, what's the magnitude of acceleration due to gravity? I don't like the fact that they say Earth in here, but which would normally imply that the value is 9.8 meters per second squared, but in this case I don't think it's going to end up being that, because G equals F sub G over M. So we want to find G, the magnitude of the acceleration, over 15 over 3, 15 newtons, divided by a mass of 3 kilograms. So that would be 5 meters per second squared, which means that you're pretty darn far away from the Earth. You're not anywhere near the Earth's surface. The acceleration is 16 meters per second. What's the weight of the object? So 16 meters per second equals F sub G over M, 6 kilograms. So F sub G is 16 times 6. 96 newtons. Okay. This is pretty similar, except it's now doing ratios. So it says the magnitude of acceleration is twice as great on the surface of planet B as it is on planet A. What's the ratio of the weight of mass X on the surface to its weight on the surface of planet B? So the mass is the same, so the mass won't change, but if M is equal to F sub G over G, just rewriting this equation here, you know that planet 1 is going to equal planet 2. So we're trying to find the ratio of on the surface of planet A. So F sub G1, I'm going to just take this equation that I set up, saying this mass is equal to this mass, which, and since mass is just the ratio of the weight to the acceleration due to gravity, we can set those two sides equal, and you get F sub G1 or F sub G2, that's what it's trying to find, is equal to G1 over G2. Or if you wanted to change those to A and B, you could do that. You want F sub GA over F sub GB, so it's GA over GB. The magnitude of acceleration due to gravity is twice as great, so this one is 2 GB, so that's twice as big. So 2 GB over GB is equal to 2 over 1. 15 kilogram mass weighs 60 newtons. After falling for 3 seconds, the acceleration of the mass is, well, 6 seconds doesn't affect anything. The acceleration should always be the same. So G is F sub G over M, 60 newtons over 15 kilograms, 4 meters per second squared. What relationships between the mass of the satellite and the satellite's distance from Earth? So the mass should not change, the mass is constant, so that one shows you the constant mass. Even as you get further away, the mass is the same. What is the magnitude of the gravitational force between an electron and a proton separated by a distance of 1 times 10 to the negative 8 tenth meters? Okay, definitely a tricky problem. F sub G equals G M1 m2 over r squared. And I know you guys will probably love doing this equation, and you're going to love it even less once you see the values we need to put in. 6.67 times 10 to the negative 11th. That's your value for G right here. The mass of a proton and the mass of an electron. So let's look here. Rest mass of a proton, 1.67 times 10 to the negative 27th. Rest mass of an electron, 9.11 times 10 to the negative 31st. Divided by the distance squared, 1 times 10 to the negative 10th squared. So we need to put this in the calculator. So watch what I do here. 6.67 e negative 11. E means times 10 to the negative, or times 10 to the something, times 1.67 e negative 27 times 9.11 e negative 31 equals, very small number, 1.01 times 10 to the negative 27th. And you're going to take and divide that by 1 times 10 to the negative 10th squared. So let's divide that by, and I'll put parentheses down here because sometimes 1 e negative 10. Some people will accidentally do 10 e negative 10, but it's really just 1 times 10 to the negative 10th squared, which I know should be, I wrote the wrong number down there. Something's not right. Shoot. I wrote the wrong number down. Irritates me. Let's do this 6.67 e. And you guys will definitely write the wrong number down at points. And it would be nice if you can figure out when that happens. E negative 31. Okay, 1.01 times 10 to the negative 67th. Okay, there we go. Divided by 1 times 10 to the negative 10th squared. So let's do this. And really, I know what the answer should be. It should be 1, because the negative 10 here, we'll add positive 10 there. So it should be a positive 47th. So it should be answer A. But let's make sure we get the right one. 1 e negative 10 close bracket, square that. There we go. 1.01 times 10 to the negative 47. Okay. Gravitational force exerts between point A and B separated by distance r. If the mass is doubled and the distance is tripled, what's the new gravitational force? Not an easy question. F sub g equals g m1 m2 over r squared. So let's see, we can ignore the constants like that, and we're only changing one of the masses, so we can ignore that too. So if it's originally m over r squared, the first time you do it, let's just say you set the mass equal to 1, the radius equal to 1, you square that, you get an answer 1. Well, now we're going to double the mass, so 2 is going to represent that number there, and you are tripling the distance, 3 squared, and you get 2 over 9. So the force is 2/9 what it was before. That should make sense. It's a lot further away. Not further away weakens it. This one, again, the calculation, gm1 m2 over r squared, 6.67 times 10 to the 11th, times mass 1, times mass 2, they're both 5 kilograms, divided by distance 5 meters squared. 5 squared over 5 squared should get a 6.67 times 10 to the negative 11th. So that complicated math question you saw on the last page, a lot of times when they set these up, they're much easier than you'd expect. Okay, I'm gonna pause this for a second. Okay, back. We're now onto a balloon inflated. The velocity of the balloon is most likely caused by, well, this is a kind of easy one. Action, reaction. Air Balloon pushes backwards on the air pushes forwards on the balloon. Centripetal force, that's circular motion, no. Gravitational attraction, no. Rolling friction, no. Okay. Person kicks a 4 kilogram door with a 48 Newton force, causing the door to accelerate at 12 meters per second. What's the magnitude of the force? A lot of extra information in here. If you just notice that there's two objects, a force on one is 48 newtons, the force on the other is 48 newtons. The whole masses and the velocity and everything else doesn't matter. Now you can use those to figure out the acceleration of the person, for example, but we don't care about that right now. Tennis ball hits a tennis racket, compare the magnitude of the rack, magnitude of the force in the ball, it's got to be the same. Third law, action reaction, same force on both of them. Accelerations might not be the same, but the force is. The magnitude of the net force acting on a killing. Okay, so here we have an acceleration. Now we can figure out what that acceleration is. This is really just an F equals ma problem, but they didn't give us the a, so we need to find it. Acceleration's delta v over t. So it goes from rest to 15. 15 minus 0 is v final minus v initial over 5 seconds. So its acceleration is 3 meters per second squared. So then net force is ma, let's see, 2 times 10 to the third kilograms times 3 meters per second squared. Don't accidentally square the whole thing, it's just the unit that's squared. 2 times 3 is 6, and you get the power of 3, so it should be 6 times 10 to the third. Good. The acceleration of the block. Well, let's first figure out the net force. Is 6 to the right, 2 to the left. We're going to add those together as vectors, so it gets you 6 newtons. So 6 newtons equals ma. So A is your net force of 6 newtons divided by your mass of 2 kilograms. So 3 meters per second squared. And if you look at this, the net force has got to be to the right, because there's more force to the right than the left. So it's going to be 3 meters per second squared to the, whoops, not reading these correctly, to the right, not to the left, to the right. Okay. Horizontal force, blah, blah, constant speed, really important. I'm going to guess that that speed doesn't matter. We just need to know that it's constant. So there's a force of 5 kilogram blocks. It says if the force of friction between the cart and the floor is 10 newtons, the magnitude of the horizontal force along the handle of the cart is, well, constant speed means your forces are balanced. So if you look at the free body diagram here, they were not balanced. But in this one, it might have a similar free body diagram. Obviously, there's going to be a force up and down too. But whatever you have to the right is going to equal that to the left. 10 newtons to the right, 10 to the left. Or 10 to the left, 10 to the right. Okay. Which one will be have the greatest acceleration? If you just know the force down, the incline is going to be your gravitational force, because it's frictionless, times the sine of the angle. The biggest angle is going to give you the biggest force down, but that just makes sense, right? The steepest slope should give you the biggest acceleration. Try it out sometime. The steepest slope, I'm pretty sure, is going to be this one right here, D. You can even prove to yourself by finding the slope of these. Net force causes this to accelerate at a rate A. Free force causes it to accelerate at a rate of 2A. What's the ratio of mass 2 to mass 1? Okay. F equals ma. So the first one, you get a force divided by A equals m1. Now let's take this, m1 equals that, and repeat it for m2. So now you're using a force of 3 newtons, or 3 times F I should say, divided by 2A is equal to m2. And note these are actually variables. This is not the equation restated. We're just using a variable A to represent A. So it's what is the ratio of mass 1 to mass 2? Well, if we take this and divide it by this, m1 over m2 is equal to F over A divided by 3F over 2A. You end up getting because the F's will cancel out. And the A's cancel out, but this flips to the top. So you end up getting 2/3, 2/3. Just B answer B. We're doing really well. A man weighs 900 newtons, standing in a station elevator. Later, the scale reads 1200 newtons. The elevator is moving, blah, blah, blah. So his weight down is 900 newtons. There's some normal force up. That's reading 1200 newtons. More up than down. So there's going to be an upward acceleration. So it's not going to be constant. It's not going to be constant speed. It's going to be an acceleration. And that acceleration is going to be upwards. Constant acceleration upwards. I don't like the word constant in there because you don't know if that acceleration is constant, but let's pretend it's got to be an upward acceleration. Unbalanced forces was applied to two blocks, A and B. The relationship between unbalanced forces and the acceleration of each block, F over A. So the slope of that's going to be M, right? Because F equals MA, so F over A is equal to M. So compared to the mass of block 1, the mass of block 2 is, so let's find the slope here. The slope of this is 3 up, 3 over, so M equals 1. The slope of this over this, let's see, it goes up 2 over 1, M equals 2. Kilograms, if this is in newtons and meters per second squared, that works. So compared to the mass of block A, the mass of block B is twice as great. 2 to 1. Okay. Which represents the motion of an object that has no unbalanced forces acting on it. No unbalanced forces. So that means it is balanced, right? So balanced, that C is a little small. That means you're moving at constant speed or at rest. Either of them works. So that means you can be moving, but if you're moving, your speed's not changing. So this one has an increasing acceleration. That definitely means your speed's changing, and it's changing at a changing rate. You're rarely going to see an AT graph that's used in this. Momentum versus time. Well, we're not talking about momentum, but as speed increases, momentum would increase also. So this is increasing speed. That's a lot like this graph right here, where speed is increasing. That can be either those. It's going to be D. You're moving at a constant speed, and the slope of that is constant, which means your velocity is constant speed. Compared to the inertia, blah blah blah. Compared to the mass of a 1 kilogram or 0.1 kilogram steel ball, the mass of a 0.2 kilogram styrofoam ball is twice as great. You like how they put steel and styrofoam to try to fool you? Two forces are applied. The acceleration of the block is, this looks really similar to something we had before. Your net force is going to be 8 minus 3. So net is equal to, we'll call it -5, just meaning 5 to the left. And that's going to equal 2 kilograms. Force equals MA. So A is equal to -5/2. So -2.5, which means 2.5 to the left. Doing this right? Okay. No, clown is fired from a ball. The clown speed is 15 meters. Okay, so now we're getting into a momentum question. You've got two objects going in opposite speeds. Momentum is conserved. So P before is going to equal 0 because it's a launch, right? Before they launch, they're both at rest. So afterwards, that means that this plus this momentum is going to equal 0. So 500 times V is going to be plus 15 times 100 is equal to 0. So these two are equal. So that means 500 V equals 1500. V is going to equal 3. There should actually be a negative in here. So V is equal to -3 meters per second. But they just asked for the magnitude, I bet, I guess. Or no, they said the speed. Speed is a scalar, doesn't need a negative there. Okay, I'm gonna pause briefly. Okay, 2 kilogram cart moving east. collides with an increment. What's the initial speed of the 3 kilogram cart? Conservation of momentum. The carts stick together and come to rest after the collision. So that's important because if they come to rest, that means P after is going to equal 0 because they both have a velocity 0. So that means P before is going to equal 0. So you've got 2 kilograms times 6 meters per second plus 3 kilograms times some velocity. We don't know what the velocity is, but when you add those together, momentum is conserved, so that if P after 0 and P before 0, so you end up getting 18 plus 3V is equal to 0, so 3V is equal to negative 18, V is equal to negative 6. So answers 6 meters per second. It's asking about speed, so we don't need the negative in the answer. 2 carts initially at rest are pushed apart when a compressed spring is so another one where P before is equal to 0, because this is just like the clown problem, right? They're not moving and they start moving. So if P before is equal to that, I mean, I can almost guarantee that I don't even need to read this to take the right answer. Well, sometimes you do. But it's asking you, it's going to the speed of this. Okay, so 1 kilogram times 6 meters per second plus 2 times V is equal to 0. Its initial momentum plus this object's initial momentum, the total's got to be 0. So 6 times 1 is 6 plus 2V is equal to 0. So 2V is going to equal negative 6. V is going to equal negative 6 over 2. So negative 3. Answer is just going to be 3. Okay. A lump of clay travels horizontally to the right on a frictionless surface. They stick together and move to the right. Okay. No numbers in this one. Compared to the total momentum of the clay block and the block before the collision, the momentum of the clay block after collision should be the same. That's the whole principle of conservation of momentum. A mother pushes her child in a swing. She exerts 10 newtons of force for 0.5 seconds. What's the magnitude of the impulse? So there's more information in here than you possibly need, but impulse is a change in momentum, but it's also equal to force times time. So if you look, letter J represents impulse for some strange reason. She's doing 10 newtons times a time of 0.5 seconds. 10 times 0.5 is a half of 10, so 5 newtons times seconds. The units could also be kilogram meters per second. Okay, last question. In an automobile collision, what's the magnitude of force exerted on the passengers during this time? So J is equal to change in momentum, which equals force times time. So let's see. Change in momentum is going to be the mass times the change in velocity, 44 kilograms, times it's moving at 15 and it's brought to rest. So the final 0, the initial is 15. So the impulse is going to be 44 times 15, or negative 15 if you will. The calculator will work. 44 times 15, 660. Negative 660, and that's equal to force times time, and the time is 0.1 seconds. So force times 0.1, divide both sides by 0.1. Force 660 over 1 should be 6,600. 60 over 0.1, 6,600. Good. Okay, we have a car traveling at a certain speed, and it's saying compared to the force required to stop the car in 12 seconds, the magnitude of the force required to stop the car in 6 seconds is, this is an impulse problem, and it's one object that's changing speed, that's often impulse. J equals force times time. So the impulse for the car should be exactly the same. You could figure it out. 2,400 times 20 is going to be your impulse. It's really 2,400 times 0 minus 2,400 times 20, but 2400 times 0 is 0. So, but I don't even need to do that. And then you just put it in different times. So, I mean, you could easily do that, but, you know, if you just take the time and you double it, well, let's say you could just do it like this, 2400 times 20, technically it's a negative. If you want to have negative impulse, is going to equal force times your time, which is either 12 or 6. Solve for force. But bottom line is, if you are not changing the left side, but you are changing the right side, if you double the time, you're going to have the force. And that makes sense. You want to stop something quickly, you need more force to do so. You want to stop it slowly, you need less force. So compared to 12 seconds, to stop it in 6 seconds is going to be half as much force. Two cars having different weights are traveling on a level surface at a constant velocity. The greater force will be required to stop the car that has a greater, should end up being mass, I would think. Let's see. Having different weights, having a surface at different constant velocities. Oh, they have different velocities. So impulse is force times time. Time, which is the change in momentum, delta P. So if you're stopping them, the change in momentum is going to be, this question's thrown here to trick you. We rearrange this, force is equal to P final minus P initial, which is the change, divided by time. But your final is going to just be 0, so it's really just force is equal to Pi, negative if you want, divided by time. So if they had the same velocities, then you'd have the mass, aka also the weight, I guess, would affect it. But in this case, your answer is going to be momentum, because you don't know the velocities. You just know that the force is going to be the change in momentum divided by the time. So you have to subtract that. To take that momentum that is going to go to 0 and divide it by the time, but it's the same time. So it's going to depend on momentum. What's the momentum of a car? This should be really easy. 1200 times 15. Times 15. And the momentum is going to be in the direction it's moving, so it's going to be east. So it's not going to be B or D. 1800. Answer A. What's the momentum of a car as it travels at 30 for 60 seconds? Well, the time doesn't matter. It's just mass times velocity. This times that. 1500. That's that number times 30. So 4500. 45 times 10 to the third. So, and it's going to be east. Answer A. Okay, velocity and time. Which car has the greatest acceleration? Acceleration is the slope of a VT graph. Which one is the steepest slope? Answer D, that one right there. Okay, the relationship between speed and time. So speed versus time, the magnitude of the acceleration, well, it's also going to be the slope of that. So let's see, the slope is going to be, let's go up 30 and over 3. You could also do it by saying this is 0.00, that's 0.1 comma 10, that's 0.2 comma 20, etc. Take any 2 points, that would be 330. But the slope should be 10 meters per second squared. Displacement time graph. Which interval is the car accelerating? Well, let's see. It's going to be when it is curved on the DT graph, so from A to B. It's moving forward, but at a constant speed, so no acceleration. Stopped and moving backwards, also at a constant speed. Which two graphs represent the motion of an object, falling object from rest? Notice this is speed. That's important to know, just because if it was velocity, we might do a negative number, but it's not, it's speed. And as it falls, it should speed up. So that means the speed should increase. This one doesn't increase, so that's not the right answer. And the acceleration should be constant, negative 9.8 meters per second squared. So it doesn't matter where in its path, as long as it's a projectile, acceleration is negative 9.8. Okay, two questions on this graph. What's the magnitude of the object's displacement after 8 seconds? So let's look at the graph. This is the displacement time graph. So if we look at 8 seconds, that's this point right here. We look over to the y, because that tells us it's displacement. That means it is 0. If you look for the whole trip, by the way, the total distance it's traveled, which isn't a question that they ask, is going to equal 8 forward. Then it's standing still for 3 seconds, and then it goes backwards another 8. So the distance traveled is 16. That's where you get this number. But the displacement is how far from the start it is, and it's back at the starting point, it's 0. What's the average speed during the first 4 seconds? So for average speed, it's distance over time. So first 4 seconds, it ends up here. It's gone a distance of, what d over t, distance of 8 meters, and it's done it over 4 seconds. 8 over 4 is 2 meters a second. Which graphs represent the same motion? Okay, so let's think about it. This right here, displacement versus time, it's moving forward, but the slope's not changing, so it's constant velocity. Those look like they are the same motion. We can verify. This one's going backwards, but so the slope of velocity should be negative and it should be constant. This is not a constant, so that's definitely not our answer. dt, that's just standing still, so you can't stand still and have a velocity increasing. And displacement time, this is going forwards at a constant speed. The slope of that should be this. It should be constant, not that either. Okay, a stone is dropped from a bridge 45 meters above the surface. How many seconds does it take? Well, if it's dropped, its VI is 0, so D equals VIT, but that goes away. 0 plus 1/2 AT squared. So I'm going to solve for time. That goes away. So distance 45 equals 1/2 9.8 T squared. You could put a negative in there, just put a negative in there too. So 2 times 45 is 90, divided by 9.8, which is T squared. So T squared equals 9.18. Let's take the square root of that, and we get 3 seconds, 3.03 seconds. For what it's worth, you should probably know that all objects, if they fall for 1 second, they travel a distance of 4.9 meters. For 2 seconds, that's a total distance. If 19.6, 3 seconds is about 44.1. So each interval gets bigger and bigger and bigger. So when you fall for 3 seconds, you fall about 44 or 45 meters. Okay, in an experiment that measures how fast the student reacts, they drop a meter stick. It falls 0.2 meters. The reaction time of the student is. So this is, again, a dropped object. So it's going to use the same equation as we did before. And again, your initial velocity is 0. And we're trying to solve for time. So we're going to say 0.2 meters is the distance, is equal to 1/2 times 9.8 times t squared. So 0.2 times 2 is 0.4 divided by 9.8. So t squared is 0.04. We're going to need to take the square root of that, and we get 0.2 seconds. Human reaction time is about 0.2 seconds. Good. A ball thrown straight up with a speed of 12 meters per second. What's the maximum height reached by the ball? Well, you can do the same kinds of stuff that we have done before. VI is equal to 12, VF is equal to 0 at the maximum height, and we are looking vertically, of course. VI, VF, and A is equal to negative 9.8 meters per second squared. You want to find, well, there's different ways to do it. If you can't, you can always find the time. Time should be delta V over T, so time would be VF minus VI over, I'm sorry, delta V over A over 9.8, negative. So you get negative 12 over negative 9.8, so that's about 1.2 seconds. I'll get it more exact right here, 1.22.
And then you could put it into that equation, d equals VIT plus 1/2 AT squared. Another option to do this is you could instead just skip this thing that I just did and say VF squared equals VI squared plus 2A. So let's do that instead. VF squared is 0. VI squared is 12 squared plus 2 times 9.8 times D. So you end up getting 0 equals 144 plus that would be a negative 9.8, by the way, minus 19.6 D. So D is going to equal 144 over 19.6. Which is 90. No, that didn't work out. 144 divided by 15.6. That felt really high. 7.3 meters. And if you want to confirm this, it's traveled for 1.22 seconds, and the average velocity is halfway between 0 and 12, so 6. So then D is going to equal average velocity of 6 meters a second times your time of 1.22 seconds. Do that, 1.22 times 6, and you get 7.3. So 2 ways to get the same answer. Okay. Oil drips. This is drawn a little strangely, but that one's moving at a constant speed. That one seems to be getting further apart, so it's speeding up. This one is doing some weird constant speed, slowing down to a different constant speed. And this is just a little bit fast, slow, fast, slow, fast, slow. The further apart the dots are, the slower you're going. I'm going to guess this isn't an answer. But let's see what the question is. What pattern represents the spacing of oil drops as a car accelerates from rest? So as it accelerates, they should get further apart. That'd be answer B. A runner starts from rest and accelerates to a speed of 8 meters a second. The acceleration of the runner is A is equal to delta V over T. So delta V is going to be V final, 4 meters per second, minus initial, which is 0 because it started at rest, divided by the time of 8 is your initial, or final. 8 minus 0 over 4 seconds. So 8 meters per second divided by 4 seconds, because that goes away, gets you 2 meters per second squared. Car has a velocity of 12 meters per second, and it slows to a velocity of 2 meters per second. They are both going east. That is good to know in 4 seconds. A is delta V over T. So since they're both east, we're going to set them as positive. A is equal to V final minus V initial over time. V final is 2 meters a second. V initial is 12, and your time is 4 seconds. 2 minus 12 is negative 10 divided by 4, which gets you negative 2.5. So clearly C and D are out, right? That negative tells you a direction. That direction is going to be west. If you're not clear of that, just think about it, because acceleration and net force always go in the same direction. So if it's going east but slowing down, as it goes east, in order to go east and slow down, you have to push it to the west. So some force is pushing it to the west or pulling it west, so your acceleration is to the west. A truck with a speed of 12 meters per second accelerates to a speed of 2 meters per second for 3 seconds. What's the total distance traveled by the truck during this 3-second interval? Accelerates uniformly at 2 meters per second squared, sorry. So we're trying to find distance, and we know VI is equal to 12, we know A is equal to 2, we know T is equal to 3. So let's find an equation that doesn't have VF in it, so that's not going to work. VI, T, and A, this one would work just fine. So D equals VIT, 12 times 3, VIT, plus 1/2. A is 2, T squared is 3 squared. So 12, 24, 36. Your answer is 36, plus 1/2 of 2 is 1, plus 9. So that's going to be 45 meters right there. A cart moving across a level surface accelerates uniformly at 1 meter per second for 2 seconds. What additional information is needed to find the distance traveled during this 2-second interval. So you are going to probably use kinematics for this, right? Which means you need 3 of the 5 variables, VF, VI, AT, and D. So there's 5 variables, but you only need 4 of them in a particular equation. So to solve for one of them, you just need the 3 other. So those, I mean, there's nothing about coefficients of friction, nothing about mass, probably not force, we just need a velocity. Coefficient of friction can help you get the force, but it's not necessarily going to help you solve this question. Especially since if you had the force, you could potentially get, if you had the force and the mass, you could potentially get the acceleration, but they give you the acceleration, so that's not going to help you solve that. Okay, a ball starting from rest, uniform, how much time to roll 40 meters? So D is equal to 40, VI is equal to 0, A is equal to 5, we don't know VF, and we need to solve for time. So let's see, 40 equals, let's use this one because we need something that has time in it, right? So we could use this equation here, 40 D equals VIT. VI is 0 plus 1/2 times your acceleration of 5 times your time squared. So 1/2 of 5 is 2.5. So T is going to equal, well, T squared is going to equal 40 over 2.5. 40 divided by 2.5 is equal to 16, and the square root of 16, because that's T squared, is going to be equal to 4. So T is the square root of 16. A race car traveling along at 10 meters per second accelerates, the final speed of the race car is, so we need VF. We know that VI is equal to 10, A is equal to 1.5, D is equal to 600, and we need to find the final speed VF. So if we look at these, let's try this one. VF equals VI squared plus 2AD, because it doesn't have time, that's a timeless equation. So VF squared equals VI squared, which is 10 squared, plus 2AD. So VF squared is equal to 100 plus 450, if I did my math correctly in my head, or 550. So VF is the square root of 550. So let's do the square root of 550. 23.4. So what did I do wrong? Because that's not an answer right here. Traveling at 10 meters a second, accelerates on. So let's see, 2 times. Oh, I did this wrong. That's not 450. I did a half of 1.5 times 600. Yeah, be careful. Okay. Lucky that I got that. Times 600. So that's 1800. So it's actually a total of 1900. So VF is a square root of 1900. $43.6. So I'm going to go with 44, rounding up. That's a very small amount compared to the rest of it. So the initial velocity doesn't actually have a huge amount of impact on that. Okay, baseball pitcher throws a fastball. You got a VI of 42 meters per second. You got a D of 18 meters. How much time does it take to reach the ball? The batter. This is actually a projectile question, and interestingly enough, we only have 2 variables, but this is going at a constant speed. So if constant speed, D equals VT, so time is just distance divided by velocity. 18 meters divided by 42 meters per second. Divide the two, 18 divided by 42. We should get 0.42 seconds, 0.428. Answer D. A car traveling between highway markers in 10 seconds. The average speed of the car. Average speed is distance divided by time. So this works for this equation here, works for this problem if we use average speed, assuming that it's not changing speed, or assuming that we know the initial and the final, and it has a constant acceleration. So in this case, you've got a distance. It went from 100 to 250, so the distance traveled is 150 meters. The time that it takes is 10 seconds. 150 divided by 10, 15 meters per second. A car having an initial speed of 16 meters a second is brought to rest in 4 seconds. How far does it travel? It's brought to rest, so your VI is 16 and your VF is 0. And the time is equal to 4 seconds. So we need to find an equation that works to find D when we don't know acceleration. Now, this is often tricky because you'll look at these, and most of these equations have acceleration in them. The ones that don't are delta V over T. That doesn't have a distance in there, or D equals V bar equals D over T. So we can use this, or you could calculate acceleration either way, but let's just use this very top one right here. And so V average is really just 0 plus 16 divided by 2. That's 8 meters per second. That's just your average. So D is equal to 8 meters per second times your time of 4 seconds. So that should be 32 meters. Two cars are 400 meters apart. Car A travels east at 30 meters a second. Car B travels west at 20 meters a second. How much time elapses before the two cars collide? This is definitely a trickier question because they're both traveling and they don't have to travel the same distance. So let me think. Okay. So I made some mistakes the first time I did this. I'm going to redo this. Two cars are going 400 meters apart. Car A is traveling east at 30 meters a second. Car B is traveling west at 20 meters a second. How much time elapses before they collide? Let's just simplify this and say they need to go a total distance of 400 meters. And their combined speed, one's going east at 30, one's going west at 20, so their combined speed is 50 meters a second relative to each other. So if they need to go 400 and their combined speed is 50, time is going to just be, if D equals VT, time is just D over V, 400 divided by 5, which gets you 8 seconds. That's a tricky question. I don't like questions like that, but occasionally they do pop up. And let's finally do 102. A box of mass M is motionless on a frictionless inclined plane by a rope. It's motionless, which is good to know, so forces are balanced. And it says draw and label all the force vectors. So there's no friction. So you do have gravity that always points down. It's on a flat surface, so you're going to have a normal force. And you're going to have a tension force up. We're going to connect that here. We can just do that. We're going to say tension. And that's it. That is my answer. I'm boxing it to try to clear the mess around it. 3 forces. There's no friction.